Now we're going to work through an example of calculating the stationary points for our function f of x, where our equation is a half x to the power of 4 plus 1 over 6x cubed minus 2x squared plus 2. Our stationary points are given when our derivative is equal to 0. So we're going to calculate our derivatives. So I'll leave the rule up here just in case it's needed, but we'll calculate our derivative straight away. So our derivative, f prime of x, is going to equal the 4 is going to come down, so we'll end up with 4 over 2, which is going to give us 2. X to the 4 minus 1 is going to give us 3. Plus the 3 comes down and gives us 3 over 6, which is the same as 1 over 2. X to the 2 minus 2 times 2 is 4. X, and the plus 2 disappears. Now that we have our derivative, we set our derivative equal to 0, and that means we can find our stationary points. Looking at our derivative, we can see that x is common in each one of our variables here. So we can actually start factorizing this and pull the x out the front. So we get x outside of 2x squared plus 1 over 2x minus 4. Looking at our equation now, we can see that if x is equal to 0, it doesn't matter what is in the brackets here, because anything times 0 is going to be 0. That means that we can solve our equation 2x squared plus 1 over 2x minus 4 is equal to 0, and that will give us our other two stationary points. Now I'm going to be solving this using the quadratic formula. So to do that, I'm just going to times the entire thing by 2. So we'll end up with 4x squared plus x minus 8 is equal to 0. Now we can just plug this straight into our formula. So x is going to equal minus 1 plus or minus the square root of 1 squared minus 4 times minus 8. And all of that is going to be over 2 times 4. So our minus 1 stays there, plus or minus. 2 times 4 is 8. Square root comes in. Our 1 squared is going to be 1 times 1, so it's just going to be 1 minus. But we've got another minus here, so two negatives make a positive. 4 fours are 16, is 128. So simplifying that, we get minus 1 plus or minus the square root of 129 over 8. Now we've got two values there because we've got a plus and a minus. So when we go ahead and calculate our stationary points, we're going to have 3 stationary points. When x is equal to 0, when x is equal to minus 1 plus the square root of 129, all divided by 8, and the point when x is equal to minus 1 minus the square root of 129 divided by 8. So because they're stationary points, we need to determine the value of our f of x at each one of these points. So the first one, when x is equal to 0, is going to be a nice one to begin with. So our f of 0 is going to equal 1 over 2, 0 to the 4, plus 1 over 6, 0 cubed, minus 2, 0 squared, plus 2. Now each of these components, seeing that they're times by 0, are going to equal 0, so our f of 0 is just our last one, which is 2. Now working with our next value of x, so our f of minus 1 plus the square root of 129 all over 8 is going to give us 1 over 2 outside of minus 1 plus the square root of 129 over 8 to the power of 4 plus 1 over 6 outside of minus 1 plus the square root of 129 over 8 cubed minus 2 outside of minus 1 plus the square root of 129 over 8 plus 2, which unfortunately is very hard to do. So I've plugged it into a calculator and I get 129, the square root of 129, minus 193 over 3072. So that's our first two stationary points. And for the final stationary point, when f of minus 1 minus the square root of 129 all over 8, well, I've done the same thing and just plugged it into a calculator at the end. And this gives us minus 193 minus 129, the square root of 129, all over 3072. And that gives us our stationary points, which are written as these. So now let's look at this on a graph. So we've got our original function here in red. And when we put in our stationary points at these three locations, when our derivative is equal to 0, these are our point values.